Our next sorting method is insertion sort. To take the logic behind the insertion sort, it iterates consuming one input element each repetition and grows a sorted output. Each iteration ins- insertion sort removes one element from the input data and finds the location it belongs within the second list, and it repeats until input elements remain. Once all the inputs are visited, then it will stop. So any doubt with respect to selection sort?
No, ma'am.
The next method is insertion sort. Here also the algorithm steps are given. Step 1, start the program. Step 2, for I equal to 1 to the length of array. Step 3, I is assigned to j, and j loop j is greater than 0, and a array of j minus 1 greater than a of j. So the a of j is compared with a of j minus 1, the previous element, and swap if a of j minus 1 is small and a of j is greater, then swap and assign a of j minus 1 is assigned to j, the minimum position. The process will be repeated until all the elements are swapped. So here if you take the program is in C or C++.
C++.
So if you take the bubble sort, insertion sort, and selection sort, all three programs, the logic is almost same. We will be taking an array of n numbers, and we'll use two for loops for for I equal to 0, I less than n, I plus plus, and j equal to I plus 1, and j less than n minus 2, j plus plus. So we need two for loops so that we will take the first number and that number will be compared with all other numbers. So the main program almost same for the selection sort, insertion sort, and bubble sort. Only that within the function selection sort, the logic may differ. So if you take the main program, so the main program starts here and your main program ends here. The return type of the main program is integer, so it has to return 0, and within the main program we are calling the function insertion sort. So while calling this function, before calling the function insertion sort, we are declaring the local variables, size of the array, index variable I, and an array of list of 30 numbers. Enter C out, enter the number of elements C in n, size of the array. C out, enter the numbers, and for I equal to 0, I less than n, I plus plus. So within using for loop, read all the array elements. So the list of the numbers is read from the keyboard. Okay, we are reading the array of n numbers. After getting the list of array of numbers, you call the insertion sort function. To the function, you pass the complete array and the size of the array. So the function of insertion sort takes the array and the size of the array, and the corresponding function will be called. And within the function, what we are doing, We are taking two for loops for I equal to 0, I less than n, and here instead of two for loop, we are taking one for loop and one while loop. The position takes the index 0 position. When the position is greater than 0 and the position is array of position is position minus 1 is greater than t, when the condition is satisfied, then assign position minus 1 to position and position minus minus. So here, using this logic, the first smallest element from the array is found, and the particular element is placed in the first position, where t is the initially t takes a of 0, where a of 0 is the index 0 position. I equal to 0 and a of I is index 0 position. That number is assigned to t. Then we are taking the index 0 position. That index 0 position is compared with all other elements in the array. By comparing the first element with all the remaining elements in the array, we are finding out the smallest number. If the first element is greater and any number in the array is smallest, then the first smallest number from the list is found. That number is assigned to position T. So in that way, the first smallest element is found and that is placed in the first position. And the process repeats until the second smallest number, third smallest number, and that will be placed in the corresponding positions. In that way, all the elements in the array are sorted. The sorted array is passed to the main program. And now, if you see out for I equal to 0, I less than n plus I less than n, the list will be having the sorted elements. List of all the sorted numbers will be available. Any doubt in the program?
No, ma'am.
Selection sort. So today we discussed first insertion sort, then we discussed selection sort and insertion sort. Our next topic is using the brute force or general approach. We can perform the following sorting method: bubble sort, selection sort, and insertion sort. Okay. Say for example, how the sorting method works. Then this is the same general traditional method of brute force approach is used to find out the linear search. Linear search we already discussed along with unit. The method or technology what we are using to search using linear search is called brute force approach, and the methodology used in selection sort, insertion sort, and bubble sort is called brute force approach. To know how the sorting works. The screen is visible now.
Yes, ma'am.
Yes.
What you are seeing in the screen? What you are seeing in the screen?
Random, nearly sorted reverse
Yes. So for
insertion
example,
selection.
if you want to sort the given numbers using bubble sort, how it functions means it is bubbling the elements, all the elements in the array. In that way, it is finding out the first smallest, and that is placed in the first position in case of bubble sort. Say for example, if you take the selection sort, how it is performing means it searches all the elements in the array, finds the first smallest and place it in the first position, and finds the second smallest, place it in the second position. So in that way, it is functioning. If you take insertion sort, it searches the elements, but it takes the first position and it compares the first element with the remaining elements. And if the first element is greater and the number to be compared is smaller, then both the numbers are swapped. Again, the second number is compared with the third number is compared with fourth. Like that, we are inserting the smallest number by swapping, then we are finding out the solution. So that is the main difference between insertion sort, selection sort, and bubble sort. If you take the merge sort, how it is functioning means it is merging the first two numbers, third and fourth number, the fifth and sixth number, and then sorting, then so merging and sorting, merging and sorting. In that way, it's sorting the entire array. And in the same insertion sort, selection sort, and merge sort, if the numbers are in random, its performance is different. If the numbers are partially sorted, the performance is different. And if the numbers are totally in the reverse order, say you want to sort the numbers in ascending order, but the number is in descending order, its process is totally different. So the array is in a reverse ordered. Then while sorting, it takes the full effort to sort the given numbers in case of insertion sort. If the number is input is in totally reversed order in case of selection sort, say it is by taking the first smallest from the last place and placing it in the first position, taking the second smallest from the second place and placing it in the second smallest position, that way. And if the numbers are in totally reverse order, in bubble sort, see how it is taking the, like selection sort and bubble sort, it is taking the smallest and placing it in the correct position. And if you take the merge sort, if it is the numbers are in reverse, totally reverse order, it performs divide and conquer, and it performs finds out the smallest number. Nearly sorted, reverse sorted, and few, if some few unique values are there, in that case, if you take the insertion sort, how it is performing means, so any doubt in this?
No, ma'am.
Have you gone through the textbook? The screen is visible.
No, ma'am.
Hope the screen is visible.
Yes,
Okay. If you take the insertion sort, how it is functioning means, say for example, if you are playing in chords, I will be arranging the chords. We'll be taking the new chords and we'll place it in the correct position so that it is matching. The same way, you take the insertion sort. So this is our given array, input array, where we are having 6 numbers. We are taking the first 2 numbers to start the process. The first number is 5, second number is 2. A loop starts from 0 and J loop starts from I plus 1. The first 2 numbers are compared. Here 2 is small, 5 is greater. We need to swap. This will be swapped. Then it will go to 2 comma 5. Then the second number is compared with the third number. Here 4 is small, 5 is greater. So we need to swap. So 4 comes here, 5 goes there. Then in the third iteration, now 4 is compared with 5. 4 is small and 5 is greater. Then 4 comes here, 5 goes here. Then 6 is compared with 5, but 5 is small, 6 is greater, so we'll leave it. Then what we will do? We'll take 1. 1 is compared with this, and 1 is smaller than 2. So the 1 should be placed in the first position. When you compare the fifth element, index 6 element, that is less than the fourth, third, 2 as well as 1. So it has to come from this position to this position. Then, so 1 comes here, the remaining numbers comes this side. Then 3 is taken. 3 will be compared with 6 greater. Again 3 is compared with 5. 5 also greater. 3 is compared with 4. 4 also greater. Then 3 is compared with 2. 2 is smaller. So 2, 3 should come here. So in that way, we are sorting all the elements. We are finding out the first smallest, and that is placed in the first position. The remaining elements are compared and it is inserted in the respective position. So in that way, the insertion sort is working. So we already discussed insertion sort. We have 2 for loops. We will compare and swap. Usually the insertion sort is a traditional. It's using brute force approach. So its computation time is not much efficient one. It aims to identify the best choice among the several alternative algorithms. Requires an agreed upon model of computation shall use a generic one processor random access mechanism model of computation. So we were talking about the time complexity and space complexity. So in that case, all the so any doubt in the insertion sort?
No, ma'am. The screen is visible now. No, ma'am. It's not visible.
So any doubt in brute force approach, how we are performing? Selection,
ma'am.
insertion sort, and bubble sort. Any doubt? Because if you take the unit 2, we have two important things. One is using brute force approach. Another one is using divide and conquer approach. So using brute force approach only we are solving. Using brute force approach only we are solving.
Ma'am,
Yes.
ma'am, can you share us the link of the animation of all the sorting relation?
Yes, I will mention it in the PPT reference.
Okay, ma'am.
Yes, if you take the brute force, we are studying two major methods in sorting and searching. One is brute force approach, another one is divide and conquer approach. Using brute force approach only, we are solving a bubble sort, selection sort, and insertion sort, and searching sequential search. And we are using the divide and conquer approach. We will study what general method. Then using this divide and conquer method only, we are sorting merge sort and quick sort and binary search. What is the divide and conquer approach? Any idea? Where and all we are using? Where we are using the divide and conquer approach?
Ma'am, in divide and conquer approach, we divide the problem into small parts and we then solve the small parts and combine the solution.
Okay. Can you give some real-time examples? Where and all we are using? Every day we are using in so many places. Can you mention in programming or in the operating system or in the device drivers or any software, hardware, application projects or in system software projects? Where and all we are using this method? Say that day we discussed queue concept is used in printer queues. The same way, where we are using this concept. Give some example. So in the first unit itself, we discussed to divide and conquer with respect to word sort. Any doubt with that?
No, ma'am.
Okay, how many of you completed the lab observation? Two programs I said from the syllabus.
Completed, ma'am.
Completed, ma'am.
Okay, any doubt so far?
No, ma'am.
Okay, so far we were discussing about the brute force approach. Then our next topic is divide and conquer approach. So in this, we will see what is the general approach of divide and conquer. Then sorting methods using divide and conquer with respect to merge sort and quick sort using divide and conquer approach, and binary search using divide and conquer approach. In general, what is the divide and conquer means? The screen is visible.
Yes, ma'am.
Yes, ma'am.
We know very well divide means you might have studied in LKG, UKG pictures. There is an you can see a picture. What is that story? Divide and conquer. Might have studied the first story. One is crow story, throwing the stones in the water. The water is coming up. It's drinking the water. Another story, lion and cow. What is that story? In a forest, there is a lion, and there are four, 5 cows. The lion tried a lot to catch the cows, but all are totally united. The lion cannot able to catch any cow. Then what he did? How the lion conquered? One of you, Kazak Singh. Tell me the story. So if you divide the
And
cow,
he might have divided them.
what?
He might have divided them, like he will catch first and the second and third, not with each other.
So it divided the cows. It made some conflict among the cows. And when the cows are separated, then easily the lion attacked. How it is, how it attack means when if you see all the things, all the parameters together as a single entity, it is very tough to find. Once the lions are once the cows are separated, then it easily attacked and catch. The same way, when you see the problem in front of your face, it may look very big, but if you divide the problem into small separate small entities, then you can easily find out the solution the same way. So what is the logic behind? To see the problem as a whole, it may look very complicated, but if you divide the problem into small pieces, or a small in the small subunits of the problem, and if you find the solution for each problem at it one at a time, then you can easily find out the solution for the entire problem. Okay, in the same way, what is the logic behind divide and conquer approach means? It is a recursive approach. Recursive means it is an iterative approach. We have to repeat the process until we will get the correct solution. And in divide and conquer approach, what is the first step means? First, divide the problem into subproblems that are similar to the original problem, smaller in size. So that is the first step. Second step is the subproblems by recursively. Solve the subproblems recursively until you get the correct solution for each and every subproblem. If they are small enough, just to solve them in a straightforward manner. So find out the solution using the normal brute force approach. Now you will be having the solution for all the subproblems and combine the solutions to create the solution to the original problem. So that is called divide and conquer approach. Say in per semester you are studying 6 subjects. I think the screen is visible now. You are studying 6 subjects per semester, and if you see all subjects, instead of a semester you are studying 6 subjects, but each subject is having its own timetable. You have separate classroom hours, working what is that homework hours, and separate mid exam, final exam. So you are the big collection of all 6 subjects divided into small components, and each subject is having its own internal marks as attendance marks, lab component marks, theory component marks, mid exam marks, final exam marks. In that way, day by day you are solving and getting scoring the marks. Your mid exam marks are already, once your mid exam is over, your 30 marks is assured, and once you submit the assignments, your marks are assured. Once you attend all classes, your attendance marks is assured. So in that way, every day you are gaining the marks for, you are getting the solution for the complete semester. At the end, you are getting calculating the CGPA for the 6 months or the particular semester CGPA. So if the problem is very big, divide the problem into subproblems and find out the solution for each subproblem recursively using traditional or brute force approach, and you combine all the solutions to get the final result. Say for example, the merge sort is a best example for divide and conquer approach. Here the problem is sorting problem. Sort a sequence of n elements into non-descending order. Here what we are doing, we are following the 3 steps: divide, conquer and combine. Divide the n element sequence into sorted into 2 subsequences of n by 2 elements each. So the big list of n numbers is divided into n by 2, n by 2. Conquer sort the 2 subsequences recursively using the merge sort. Again the n by 2 is made into n by 2 by 2. So n by 4, n by 8. So yeah, at the unit level we are solving this problem, and we are combining the things together to get the final original result. So divide, conquer, combine, merge the 2 sorted sequences to produce the sorted answer. So these are the 3 steps followed in merge sort also to get the final solution. If you take the merge sort, so this is the given original sequence. The original sequence is having total 8 numbers. The sequence is having total 8 numbers. Now we need to find out the midpoint. In the midpoint, we are dividing the sequence into 2 of one side 4 elements, another side 4 elements, lower boundary and upper boundary. Add both the boundaries and divide by 2, we'll get the mid element. Then again this subsequence is divided into 2 of, again the unit level, compare the 2 elements and sort. Again here you compare and sort, here you compare and sort. That way you are sorting all the elements. So the merge sort algorithm, how it is functioning means divide the stage, conquer the stage and combine stage. They given unsorted list of n numbers, n by 2, n by 2, unsorted. Then perform the merge sort recursively here. Find the sorted list of n by 2 elements and perform the merge sort recursively here for the n by 2 elements. Again, while calling recursive merge sort, that will divide into n by 4, n by 8 like that. Then we'll get the n by 2 sorted list. Merge the n by 2, n by 2 sorted list. Merging is done. Then you will get the sorted list of n numbers. So this is the logic behind merge sort using divide and conquer technology. Any doubt in this? Any doubt in what is divide and conquer and how the merge sort is performed? Any doubt?
No, ma'am.
Okay.
Again, if you take the unsort merge sort, this is the given list of numbers. Already we discussed. We are merging and sorting, again merging and sorting, merging, then sorting. So in that way, we are getting the solution. So divide, conquer, and combine. And if you take the merge sort sequence of steps, We have the merge sort. We'll take the array and the index variables p, q, or p is the lower boundary, q is the upper boundary, and we need to find out the mid element also. So we'll find out the n1 by n2, and using for loop I equal to n2, I to n minus I for I equal to n2, 1 to n, L of I, the list of I. The first element is compared with the search. We need to take the searching element, then the searching element will be compared with the mid element, and depending upon the value of the array elements, we need to swap. So the given array of t of n numbers, t of n by 2, n by 2, then n by 2 into that will become n by 4, n by 4, n by 2 becomes half and quarter, like that. Then we will combine together to get the complete. And the dividing goes from n elements, n by 2, n by 4, up to single entity. So any doubt in the merge sort logic? We'll discuss the program tomorrow. We'll try to use some animation so that you can easily understand. We go through it. Today we discussed the brute force approach. What is brute force? We saw the definition. Then we discussed how the general brute force approach, common man's logic, is used in bubble sort, selection sort, and insertion sort, as well as we already discussed in linear search. Then we discussed what is the divide and conquer technique, the general method. Then we discussed how the divide, conquer, and combine is used in merge sort. So in the next class, we will see what is the pseudocode, program, efficiency, and the C and C++ program for merge sort as well as quick sort. In quick sort, how we can use the divide and conquer. Then we will use see this merge sort, quick sort, and binary sort programming, as well as the logical flow using some diagram. So go through the, already I uploaded one material for all the sorting methods using brute force approach as well as divide and conquer. You go through the content. If you have any doubt, ask me in the next class. And the class will end in another 1 minute. And one more thing, you have to join once again to take the attendance. Okay? All of you listening?